improper if, for example, when you substitute one of the values, you get division by 0, or there's an asymptote, or perhaps one of these limits is infinity. In this case, we have the idea that if x equals 3, we're dividing by 0. So before integrating, I think I want to get an idea as to what's happening by graphing the function. So that's 2 divided by the square root of x minus 3. And I need to see what's going on from 3 to 5, so I'm going to change the window to be 2 to 6. Not really sure what the y values are, so I'm going to guess negative 5 to 5. Then take a look at the graph, and it looks like here at x equals 3 there is an asymptote. But the idea is, if we integrate and find the area under the curve, does this area right here add up to infinity or not? We can ask the calculator for an approximation, so go to integrate. Now 3 is a problem, so I should not plug in x equals 3, but instead something just to the right of it, so 3.001, let's say. And then with 5 as the other limit, that's not a problem, so just plug in a 5. And the calculator estimates the area to be simply a 5.53. So it looks like this area over here, even though it's infinitely tall, must be really skinny up there because it does not add up to infinity. Then let's actually prove it. So over here we can use u substitution. U equal the x minus 3. The derivative of that is just going to be dx. So with the 2, I could just factor that out, and then I would have the integral du for the top to replace the dx, and then it's the square root of u. Notice that I'm not using the numbers 3 and 5 because those are for x's, and right now I'm in the u system. So what I do is just integrate, and when I'm done integrating and I've replaced the x's, then I put the 3 and the 5 back. So with this one, it's going to be rewritten as u to the negative 1/2. Excuse me. And then in order to integrate, so add 1 to the exponent, and that's going to be u to the 1/2 divided by 1/2. And you can invert and multiply, so that's going to be 4. And then change the square root, with the 1/2 back to square root, change the u to x minus 3, and now that we're done integrating, then put the limits 3 to 5. So it's going to look like 4, and then when you substitute a 5 in here, it's going to be the square root of 2, minus 4, and then when you substitute a 3 in here, that's going to be 0. So the answer turns out that it's not infinity. It is in fact 4 radical 2. Let's see how close the calculator was. What is, so the calculator said 5.53. 4 radical 2 is the actual answer. 5.657, so the calculator is fairly close.